Maxima and minima. Let's talk about the extreme value. Let f be the function with the domain D, then f have an absolute maximum value on D at the point C if f of x is less than or equal C for all x in D. So let's take a look at this situation. So we have a graph in this domain D. Let's call this from A to B. And we have this value here at C. So this point here, C, f of C, is called the absolute max of f of x on the interval AB. Okay, so note that the value of f of C is larger than any value that right next to it. Yeah, that's what it's saying. Similarly, f had the absolute minimum on D at a point C if f of x is greater than or equal C for all x in D. F have a local maximum value at a point C within its domain of D if f of x is less than or equal C for all x in the domain lying in some open interval contained in C, has a local minimum value at a point C within its domain D if f of x is greater than or equal if f of x is greater than or equal f of C for all x in D lying in some open interval contained in C. And you can see it with this specific picture here. And we can see here, well, we have an absolute maximum. So in this case, we have how many maximum? We have a local maximum and we have an absolute maximum. Yeah. So the absolute maximum, they have no greater value of x anywhere. The local maximum in this case, it is the maximum in this interval AE. The local maximum here, it is the maximum in the interval AE, but not on the entire domain AB. Similarly, you have here the absolute minimum, the smallest value of the function. You have a local minimum. This is the smallest value in the interval from C to D. And again, we have a local minimum in the interval from D to B. Okay. Let's take a look at the first example. Given the graph of f of x equal x to the third plus 2x squared plus 1 on the interval -1, 3, identify the extreme value. Here we have a closed interval. This means that we include this value here and here. So at this point, this is 1, 4, and this value here is -3, -8. Okay, so let's talk about the maximum. We have the absolute max at x equal 1 max value f of 1 equal 4. Notice that there's a difference between the maximum at and the maximum value. So when we talk about being maximum at, we're talking about x, but if we're talking about a maximum value, we're talking about f of x. Okay, we have a local max at x equal this value here. Let's say that is -1.5, and max value f of -1.5, that is equal 2.5. We have a local mean. So local mean at x equal to 0, min value f of 0 equal 1. We have the absolute min at x equal negative 3, min value f of negative 3 equal to negative 8. We can use the first derivative theorem for the local extreme value. If f have the local maximum or minimum value at the interior point of C of its domain, then f prime is defined at C. And if f prime is defined at C, then f prime of C equal to 0. So note that if you compare the local maximum and the local minimum here in this graph that we're looking at, note that the slope of the tangent line at those point is 0, right? So f prime of C equal to 0 there. Definition: in interior point of the domain of the function where f prime is 0 or undefined is the critical point of f. Okay, so we're talking about the interior point. So let's take a look at this. We want to find the absolute and local extrema of the following. So we first will find the critical point. So the first step is to find the critical point. I first start find f prime of x. F prime of x in this case equal to 4/3 x to the 1/3. F prime of x equal to 0. That imply 4/3 x to the 1/3 equal to 0. So the critical point is x equal to 0. Now we want to take a look at the extrema of the graph within this interval from -1 to 8, and we have 0. So we need to test out what are the value at those critical point. So then we find the value. We calculate f of x at critical value. And endpoint. Okay. At x equal to -1, f of -1 equal -1 to the 4/3 equal 1. F of 0 equal to 0. X equal 8. F of 8 equal to 8 to the 4/3. That is cube root of 8 to the 4th. That is 16. So note that here we have the absolute max. We have the absolute min. Excuse me. We have the absolute min at x equal to 0. Okay, so here we have the absolute mean. Note that we only find the local, we only find the absolute max at we only looking for the absolute and local extrema, right? So at x equal to -1. So let's take a look at this. The shape of this graph of f of x equal 4 to the x to the 4/3 is somewhat kind of like a parabola-ish. You can look at it like this, right? Okay. So then the value at x equal to -1 doesn't have anything to do with the so at x equal to -1. So it's somewhere kind of like here. So if you just take a look at the graph in this interval, -1 to 8, gonna look like that. So then at the point that is x equal to -1, we have a local minimum, local maximum. Okay. In the next one, we look at f of x equals sine of x. Okay, so for first step, we find the critical value. F prime of x equal to cosine of x. Cosine of x equal to 0 when x equal to pi over 2, 0. So we look at x equal is in the interval, right? Negative pi over 2 to 5 pi over 6. What do those look like on a unit circle? Negative pi over 2, start right here. 5 pi over 6 is over here. So in this interval, x equal to 0, cosine of x equal to 0, at negative pi over 2, at pi and at pi over 2. Okay. So cosine equals 0 here and here. So let's calculate f of x as the critical value. At x equal to negative pi over 2, f of negative pi over 2 equals sine of negative pi over 2, that is -1. At x equals pi over 2, f of pi over 2 equals sine of pi over 2 equal 1. At x equals 5 pi over 6, f of x, f of 5 pi over 6 equals sine of 5 pi over 6, that equals 1/2. So note that the graph of sine is kind of looking like this. So here's negative pi over 2, 2 pi, pi over 2, sine gonna look like that in that interval. Okay, so here so as you can see here, according to that graph, we have the absolute min, absolute max, a local min. The next one, we weren't told what are the interval that is we're supposed to be considering, which means we consider the entire domain of this function. Okay? So then take a look at this critical value. F prime of x equal 12x to the third plus 24x squared minus 36x. F prime of x equal to 0, which means we will factor out 12x. 12x times x squared plus 2x minus 3 equal to 0. 12x, x plus 3 times x minus 1 equal to 0. So the critical value, x equals 0, x equals -3, x equals 1. So let's evaluate the function. When x equal to 0, f of 0 equal to 0. When x equal 1, f of 1 equal. When x equal -3, f of -3 equal, and I'll go ahead and use the calculator. Here we get a negative 7. Here we get a negative 135. Okay. Now time to decide whether we have a maximum, minimum, or local min, local max. So this is the graph of extra force. And so according to this, the graph of this gotta look something like this. Okay, so then this we have a local max. We have a max here. We have a local min, and we have the absolute min. In this case, let's take a look at the different possibility regarding the absolute extrema. Okay. We can have no absolute max, no absolute min in the first case. Then we accessing the graph from in the first table from A to C. We look at the graph from negative infinity to positive infinity. So you can see that for graph of f of x equal x to the third, we have no absolute max, no absolute min. In the second case, we have an absolute maximum, but we don't have an absolute minimum. And then we have the absolute max and the absolute min, and this is a periodic function, so it repeats at certain interval. And again, in this case, we have kind of a closed interval of some sort, right? And here we have an absolute maximum, and we don't have the absolute minimum, because if you think of if you look at this graph and say, well, how about the value at x equal 2? At x equal to f of negative 2 is undefined, so we can't say that we have an absolute minimum because we don't know exactly what that value is. Now here we have the absolute max and the absolute min in the next case, and we have no absolute max, and we have the absolute min at x equal to 0. So that's the different case to consider. Let's talk about the extreme value theorem. If f is continuous on a closed interval AB, then f of 10 both absolute maximum m, capital M, and an absolute value small m in AB. That is, there are a number x1 and x2 in AB with f of x1 equals small m and f of x2 equal capital M, and for m greater than f of x greater than capital M for every other x in AB. And so here we have a couple different types of graph, and you can see that on it doesn't matter how you draw a graph, and as long as it's continuous here, you can find a minimum and you can find a maximum in a closed interval, of course. Okay.